Japan? That's a country located in Eastern Asia. Nihonium, originally named nihonium, is the 113th element, and post-transition metal with 113 protons and 113 electrons with 173 neutrons. Nihonium was discovered in 2004 by K. Morita with a density of 16 grams per centimeters cubed. Nihonium has a melting point of 700 degrees Kelvin and a boiling point of 1430 degrees Kelvin, an atomic weight of 286 atomic mass units, and it was named after the name in Japanese, Nihon, which means Japan. Nihonium was made using Riken's linear accelerator facility and the Gary's ion separator in Wako, Japan. The isotope produced was nihonium-278, which does not hang around for long. Its half-life is less than 1/1000th of a second. Morita's team had begun their work in September 2003. Zinc ions, 70Zn, were formed into a beam in a particle accelerator and fired at a thin layer of bismuth, 209 Bi, in a cold fusion reaction. Using this method, the scientists believed they made a single atom of element 113 in July 2004 and again in April 2005. On each occasion the atom rapidly underwent 4 alpha decays, first to rhenium-274, followed by meitnerium-270, borium-266, and dubnium-262. These results were not sufficient to satisfy UPAC and EUPAP. In 2011, their joint working party refused to accept the discovery of element 113, stating that the work of the collaboration of Morita et al. Is very promising but has not met the criteria for discovery owing to the paucity of events, the absence of firm connections to known nuclides, and the inconsistencies noted above. The scientists in Japan then hit a dead end. Morita commented, "For over 7 years we continued to search for data conclusively identifying element 113, but we just never saw another event. I was not prepared to give up. However, as I believed that one day, if we persevered, luck would fall upon us again." To help validate their discovery of nihonium, the team carried out a new experiment which would give them a better idea of the decay chain beyond 266 pH. A beam of sodium ions was collided with a curium target creating 266 pH, which then decayed to 262 dB. On August 12, 2012, the scientists observed a third and conclusive decay event. Nihonium was created in the same way as before and underwent the same 4 alpha decays as previously. Additionally, 262 dB continued to undergo alpha decays, yielding 258 Lr followed by 254 MD. As the chain had been fully characterized, this was taken as a clear demonstration that the source of the decay chain was indeed nihonium, element 113. In 2015, the UPAC/EUPAP Joint Working Party, JWP, reviewed the work and stated that the Riken collaboration team in Japan have fulfilled the criteria for element Z equals 113 and will be invited to propose a permanent name and symbol. Nihonium is harmful due to its radioactivity. Nihonium is a synthetic radioactive metal. Nihonium is of research interest only. Source: the element has been created using a cold fusion reaction between a bismuth-209 target and zinc-70 ions. Nihonium has one isotope whose half-life is known, 278 Nh. Stay tuned for fluorovium.